This tutorial will cover fill. Fill is the process of programming an object so that the laser does not mark only the outline of the object but also completely fills or colors the object in so that it's solid. For example, if we had the letter T, the fill would allow the T to become a solid shape or solid image on your part versus just the outline. And there are a lot of ways that we can control and program this fill depending on the type of mark we're after, the type of material, or the speed that we're trying to obtain. So to start with the fill, I'm just going to come over and I'm going to draw a simple square to use. I'm just going to draw this square out using the square tool, and I'm going to zoom in a little bit here on this square so we can get a closer view and really get a good understanding of how the fill properties work. Alright, so now that we've drawn our square, to fill this object we're going to come up here to this H symbol. This is for the fill, and you can see that the indication of this icon is there's little lines going across, and what those represent is that the object is filled in. So when I click on that, it's going to launch a fill properties box. Now on each object we have up to 3 different fills, and I'll come back to that in a moment, but that's important because each fill can have its own unique settings, so to speak, that allow you to obtain a specific type of mark or look. If you reference our laser settings guide, you will see that the fill is very important in combination with the proper settings. In other words, if I'm trying to achieve a specific type of mark on a material, let's say what we call a black annealed mark, which is a very jet black surface mark on a piece of stainless or titanium, I'm going to use specific laser settings in order to obtain that mark. However, I also need to have the proper fill, because without the proper fill I'm not going to get the result I want. So it's very important that you have the right fill and the right combination of laser settings or parameters together in order to achieve the mark that you're after. So let's go down through these options from top to bottom. We won't cover every single one, but we will cover a few. Starting from the top, our first selection on our fill is mark contour. Now this is going to either allow us to mark this contour here, which is the outline, okay, so in other words mark outline or mark contour, or not mark it. If we're filled, then the laser could only process this filled area and ignore this outline if we have this turned on. Okay, the plus sign here next to the 1, if the little dashes, that is a toggle button. If I click that, you're going to see the 1 jump to the outside. What this says is, am I doing the fill first? You can see the inside here, which would represent the fill we're going to place in here, or am I doing the outside first? So which one do I process first in order of operation? If I'm set up in this method here, what we're going to see is that first the fill that we set up will process, which you can see my mouse is inside the square, and then second to the operation, if our mark contour is turned on, it will process this contour. Likewise, if we switch it, it will process the contour or outline first and then process the fill. Right below that we have fill 1, 2, and 3. These are our different combinations of fill, which we'll show you in a minute. We have whether that fill is enabled or not. Okay, if we're going to add at least one fill, our fill 1 is always going to be enabled. We're going to skip these other settings. These are deeper settings which don't apply to most applications, which you can look at, but we're going to jump right over to 3 of the most important things, which are the type of fill, the fill angle, and what's called the line space or fill spacing. So let's talk first about the angle and the line spacing. The angle is the approach that the fill or the laser is going to take whenever it is sweeping or filling in the object. So 0 degrees is in reference to the x-axis, which runs left to right across our screen and runs left to right as you're looking in your laser system. So if you place a part into your laser system, left to right is your x-axis, with the vertical being the y. So the 0 point here, the 0 angle, actually represents the x-axis. And so when I fill here in a moment, you're going to see more, and we'll come back to that. Line spacing. This is the distance between each line that is generated in order to fill the object in. So let's go ahead and we're going to process this. I'm going to enter this at, I'm going to give you a 1 millimeter fill, which is not a usable fill in most applications, but it's going to help explain what we're trying to show you in this tutorial. So 1 millimeter fill at 0 angle. I've got my other fills turned off. I'm going to click OK. And now you can see that the system has generated lines inside of our object. And so therefore when we mark this object, this square, the laser is going to process all these lines. Now these lines allow the object to be solid upon marking. Coming back to our angle, 0, you can see if this is the x-axis that the lines are following that 0 degree format. If I change that to 90 over here on the left where my fill settings are now shown, you can see I've got vertical 90 degree lines. If I change this to 45, you're now going to see a representation of a 45 degree line. Likewise, if I change it to negative 45, you're now seeing a negative 45 based off the 0 axis. So it's very simple to understand there. Let's go back to 0 for a moment. Just highlight this, change this back to 0, click apply, and now it's updated. Let's come back down to our line spacing and talk about this. I'm set up at 1 millimeter. That means when the laser marks or processes this square on my material, it's going to space 1 millimeter between each line of the fill. Therefore, if I were to mark this square on a piece of material, you could easily see the spacing in between these lines where it is not selected. Or excuse me, where it is not marked. So to get a solid fill, 1 millimeter would obviously not be enough. So to give you a contrasting example, if I come down and do a 0.5, a half millimeter, now you can see these lines are even closer. But a realistic type of fill starts at about 0.07, 0.08 millimeter and below. And now you can see our lines, the concentration of them is much greater. If I scroll in, now you can see that these lines are much closer together here. And so that's going to give you a much more solid appearance. Now it's also important to understand that the closer these lines are, the more overlap you're going to get with your marking and the more solid your mark is going to appear. Or let's say the density of the mark in terms of the fill. And this is important because having the proper fill or the proper spacing is going to allow you to achieve the mark result you want when combined with the proper parameters for your material. For our next item, I'm going to change this back to 1 millimeter because it is very important to show you how the fill type, which is right here, works. Now the fill type is going to allow you to change the way that the laser processes in terms of what it marks and what it does not mark as it fills. So starting out, we have a standard fill here. The blue line that you see on this icon here represents when the laser is on. The red line represents the laser as off. Now, if I undo my mark contour and apply that, you're going to see that the object now is only represented by the fill, and that the outline of the square is now gone because I turned mark contour off. I told the software to ignore the outline and do not mark the outline. Therefore, it's only going to mark the fill. So, as a representation for this fill type, over here you can see that the blue is on, which is this. This line represents being on, means the laser is going to process it. When it turns the corner to come up and process this next line, it's going to turn itself off. So there's no laser marking happening between this line and this line. It's just going to continue down, it's going to turn off and come back and continue down again. If I go to the next type of fill, which is a spiral fill, and apply that, you can now see that it is creating an object inside of an object inside of an object, and so on and so forth. This is a similar fill to the first one we showed you, but now if I apply this, you can see that the laser path is complete. In other words, when the laser turns the corner to come back the other direction, it stays on. Therefore, the laser is continuously staying on as it marks, as shown as you see in the sweeping of my mouse. The next fill, if I apply that to this object, is going to look the same. However, you see that there is dashed lines breaking up this blue area. For this, I'm going to scroll out momentarily and create a text box. Let me bring this text box down, resize, and let's just zoom in and move down to this text box. We're going to go ahead and fill this object, this text box, with the same fill properties that we were just referencing. However, I am going to increase this space. I'm going to put this, or decrease this space, excuse me, down to 0.2 so you get a better representation and turn mark contour off. And now you can see this dashed or dotted line fill is applied. And when I click OK, now you're going to get a representation of what that means. We weren't able to show you that on the square because it was just one object, but the way this fill works with the dashed lines is that it will stay on when it turns the corner to the left and the right, or the top and the bottom extremities of the object. However, when it comes across the object, it's going to go completely across, come up to the other side, and come back across. So when it processes this object, it's not going to do one character at a time. It's just going to come across the entire object as it marks and turn the corner. It stays on, so on and so forth, until it processes the entire object. If I come back to this fill and turn the mark contour on, you can see what that looks like. However, you cannot see where it stays on. If we were to use this fill with the mark contour, we would have a double line on our edges out here, typically not noticeable during the marking process. However, go ahead and delete this object. We're going to scroll back out a little bit, and we're just going to zoom back to our square, reselect our square, and we're going to continue through our fills. We're going to come to the last fill now, which is a unidirectional fill. And what this means is, if you can see here in the representation, the laser is on for the blue, however does turn off for the red. And the way this works, if I apply this, is it looks like just the standard first fill we saw, which is lines going back and forth. However, when the laser processes this first line as it comes across, instead of jumping up to this next line and coming back this way, which in turn saves us time and marking time and is more efficient, it's going to go down, it's going to stay on. When it's done marking this line, the laser is going to turn off. It's going to steer the beam location back to this point and start again. So it's jumping back to the beginning each time as it does each line. This fill is sometimes important for specific plastics and controlling heat. Let's come back to one of the fills that we already discussed, and for this fill we're going to move this square out of the way, and we are going to generate a new text box to show this fill property. When I fill this object, I'm going to come back to my fill where the laser stays on as it turns the corner. And I'm going to change my spacing to 0.1 so it has a tight fill, but you can still see the representation, and go ahead and zoom in here. This particular fill that we're showing you here with the on as it turns the corner, or the laser staying on as it turns the corner, this particular fill will process each object one at a time, as opposed to turning off to jump between each object and switching back and forth as it jumps across the characters. It is going to mark the T, then the E, the X, and then the T again, and it will from time to time break these characters into pieces. This fill is used particularly to optimize your speed. So this is going to give you the fastest time, because what it does is it cuts down on what we call jump times, which is jumping between one character to the other where the laser turns off, which can take significant time. You can imagine as the laser jumps all the way across, back and forth, it takes a lot longer than the laser filling the T, filling the E, creating the X, and then creating the last T. We're going to come back now to our square, and now we're going to talk about applying multiple fills. I'm going to select my square. I'm going to bring my square back over here. Zoomed in. Go ahead and turn my mark contour back on. We've explained the angle, we've explained the line spacing, Again, starting at 0.07, 0.08, and then going below. For example, if we do 0.04, is always going to be ideal. You're going to have a thicker concentration of laser beam going down on your material, which is going to give you a very solid filled in object on your material. But for this example, again, we're going to go back just to 0.3 will do us well, and now we can see some spacing in there. To add secondary fills, we're just going to select the different fill here. We're going to enable that, and to give you an example of what we would do with the secondary fill, as the first fill was programmed at 0 degrees, this second fill we're going to program at 90 degrees. And now you can see we're at 0.02. We're just going to change that to 0.3 to give you a better visual. And apply that. And now you can see that this object is filled in both the 0 degree sweeping direction and both the 90 degree. Now this is important for specific types of marking, as the laser beam has maximum surface coverage and is approaching from two separate angles. This is going to give us a specific look depending on the type of material we want to mark. Now likewise, we can also go to a third fill. We can enable that fill. Let's do 0.3 once again, but this time let's go at 45 degrees and apply that, and now you can see we have 0, 90, and 45 degrees. So since we have all three of our fills enabled at this point, the laser is going to process all three of them, and you get a visual representation on the screen of what is going to happen when it processes that. Let's talk about a couple other settings you may want to utilize with your fill. For now, I'm going to disable the third and second fills and come back to my first fill, and now you can see I've got a singular fill, 0 degrees, 0.3 spacing in between the lines. Let's look at our average distribute line. What this does is it spaces the lines or the fill lines equally within the object. For example, my square is a specific size. As you can see here, it is 15.427 millimeters wide by 14.024 millimeters tall. If I have a 0.3 line spacing, there's no guarantee that these lines are going to fit evenly across this object. What average distribute line does is it centers the fill within the object. You can see if I uncheck this and apply it, it will now space it unevenly. So you can see we've got a smaller gap or spacing between the outside of our square and the first fill line at the top and the bottom. So this is going to give you a more even look. The edge offset is going to allow us to change the fill overlap. In other words, if I were to put this at 2 and click apply, you can now see that it is giving a 2 millimeter offset from the edge to the fill. For a better example, if I were to go at 0.5, you can see now there is a 0.5 border around the edges here, and because we have average distribute line turned on, we're getting a bigger gap at the top. If I apply this now, it's going to be even all the way around. This also gives us a few other things that we can manipulate. The start offset, which is going to offset where it starts. So since it's 0, it's starting from the bottom and sweeping up. We now have a 2 millimeter start offset. Likewise, we can do an end offset to make it stop early. And we can also reduce the lines to line reduction even further. So there's a lot of different things we can do in here. We won't get into the rest of this, but we do want to show you these settings because occasionally they can be utilized for very specific applications. So for now, I'm just going to clear all this back to 0, apply this, and reapply my average distribute line. That is a brief overview of the fill. If you want to learn more about the fill settings, including the pin numbers, we're going to cover that in a later tutorial. And what that allows you to do is pick laser settings for the individual fills. That will be covered in the laser settings or laser parameter tutorial.